What's up, guys? So we got Nate Adams on the podcast. He's been on the show before. Now, he's a big fan of electrification when it comes to heat pumps, and he's set up a bunch in the properties that he owns, his Airbnbs. Nate and I get into the conversation of why maybe the go green narrative kind of ruined it for heat pumps. It should have been really focused because that's sort of a political divide there, in my opinion. It should have been focused on the comfort aspect of what a heat pump can provide, especially because it can load match. So we're going to talk about stuff like this on this two-part episode or two-part podcast. So this is Nate Adams, guys. This is the HVAC Know It All podcast. I'm your host, Gary McCready. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. All right, so if you're listening, well, I know you're listening because you've obviously gotten to this point. I'm speaking to the audience here. Electrify Everything is a group that Nate had started on Facebook. The title, Electrify Everything, a political statement for some if you take it back to that. But I think Nate and I both agree the whole heat pump thing, let's just not electrify everything. Let's just stick with the heat pump conversation for now, and we can talk about your thoughts on electrify everything a little bit later on. But you and I both agree that the whole heat pump messaging was wrong. Somebody got it wrong. They started to politicize it, like go green and stuff like that. They left out the fact that we can run an HVAC system with a high level of comfort, and we can also have some energy savings through that because we have these compressors that dial back and turn down and can match the load that's needed and not just turn on and run at 100% for 10 minutes and bang off to 0%. So I think you and I both agree the messaging was wrong. It's not about necessarily going green because there's many arguments against it on the political side. And I think that if we stuck to, hey, like these things are now built to withstand colder temperatures, they are reliable, and the comfort because of the load matching is incredible. So let's get your thought on that first of all, Nate.
So I should probably open with, I removed my first client gas meter back in 2014. So been more than a decade, which is more than most people have done. A lot of this it wasn't a political thing for me at all. I knew about the load matching side of things. So matching what the house needs at any given moment to what the equipment can put out, evens out all the surface temperatures. So the first time that I got to experience a system the way that I wanted, I walked in, a client, John Nigro, and this is the most comfortable place I've ever been in by an order of magnitude. It was 15 degrees outside. Well, depending on who's listening. So 15 Fahrenheit. So minus 10, something like that.
Let's make the assumption when Nate says a temperature, he's referring to Fahrenheit.
Fahrenheit's how I think for the most part. I can speak Celsius also. So anyway, it's cold outside. It's a 1918 house. We hadn't fixed the shell yet. And I'm thinking this is the most comfortable place I've ever been in because it was load matching exactly what that house needed. Now, it was running a bunch of resistance because it was still leaky as heck. It was a 100-year-old house in Cleveland on a cold day. Just kind of blew my mind. There's a difference between understanding something intellectually and experiencing it emotionally and physically. And that was my first kind of exposure to that. And I had sold the project. But like it's very different when you haven't experienced it yet. So that was wild. And then I had a good friend of mine, Cameron Taylor, who watches some very crazy buildings down at University of Texas, Arlington. He was brought there to handle the HVAC, a new laboratory that's 100% fresh air. So pretty intense systems on that building. He walks into another client's house. He's like, this is like womb-like comfort. He's like, where do I put my coat? And we didn't even have the house at full temperature at that point.
I want to know how he remembers what the womb feels like. That's what
right. I know. That's you start experiencing those sorts of things. And then like we're doing these cool themed Airbnbs here in West Virginia, New River Gorge National Park area. We have one that is Harry Potter themed. It's a 1950 ranch. I didn't insulate it yet. So I had to fix the basement. I joke it was a river runs through it without Brad Pitt. When we bought it, there was water just coming out the back door. But the walls are uninsulated and there's 2 inches of attic insulation. So there's just nothing really in the house. And my wife, when we were staying there one time, she's like, this is the most comfortable place I've ever been. It's got a 1.5 ton Daikin fit that's actually matching what the house needs from moment to moment. It's amazing the levels of comfort that a heat pump can provide. Or you can talk to Jim Bergman, who's a convert after me busting his chops for years, and he put a Bosch on top of his furnace at his house. And he's like, my basement is warm for the first time. since I've owned this house. The whole house feels lovely. It doesn't wake me up at night because I don't hear the furnace banging on at 3 a.m. and it wakes me up. It just runs the whole time. In the messaging, we have utterly lost the customer experience. And it's been, green and carbon, all these other sorts of things that even for the people that care, they don't spend money on it. I got interviewed a couple of years ago now, and I ticked off a bunch of people because 75% of client-focused customers suck because they usually have high expectations, but they want it to pay for itself. They want it to be cheap, and you don't get good and cheap. So they're kind of miserable to work with. So I joked, like, I'd rather pull up to a McMansion with a BMW in the driveway and a Trump sign, because that person is probably willing to buy a better piece of equipment, which is going to deliver a better experience. And experiences are really what we should focus on.
You said it was the most comfortable place that you've ever been to. This phrase here, tell me if I'm saying it right. Mean radiant temperature. Am I saying that right?
Yep. That is the technical name of what we're talking about. So mean is average. Radiant is basically the surface temperatures around you. So the easiest way I've heard it explained is you want everything in the house to be within 1 to 3 degrees of what the thermostat sets. So within 1 degree Celsius, within 2 to 3 degrees Fahrenheit. And if you can achieve that, houses feel amazing. So like the couch is warm, the walls are warm, the ceiling's warm, the floor is warm, or cool if it's cooling season. But you want everything to be as even as possible.
I'm going to give an example of that. This wasn't heat pump. It was a modulating system using a digital scroll. So the fact that you said the couch is warm. So let's say, let me just say this first. So you come home from a day of work, the thermostat, let's say it's the middle of the winter. The thermostat's set for 72 and it's 72 in the house. But you sit on the couch and the couch feels like it's
icy,
6 or 7 degrees colder than the actual room. You're like, what in the world is going on here? There's something not right with the HVAC system in that house. It must be short cycling. It's not running long enough to get that temperature or that warm air to where it needs to go. That is one of the things that you can look at that's from a dumbed down position. You sit on your couch in the middle of the winter, your thermostat's satisfied, and your couch is cold. Well, something's not right in this house. So when I worked a lot in the pharmaceutical part of the industry, the clean rooms, and I've mentioned this before in the podcast before, so the clean rooms that I'd work in, these things had customized machines that would cool these clean rooms and dehumidify these clean rooms because they had to be kept at a certain temperature, like within a range. And if it was outside of that range, they couldn't go in and do any processing of the product because now it's outside of spec. And any product that's in the room and it goes outside of spec, guess what? Now it's garbage. So if you go into that room, to get into this room, it was ridiculous. You had to go downstairs, go into a change room, put on all this bunny suit stuff, go up to another room, then go into this sort of chamber where it was neutralized or airlocked, and then you have to put on another bunny suit. By the time you got in there, it was like a 30-minute process to walk into this room. And if you took a thermal camera into this room and you went and scan. Now, thermal cameras work off of differential in temperature. That's how you see hot and cold or red and blue. If you walked into this room, you wouldn't see a differential in temperature on anything that you scanned. Nothing, because everything, and the way these work, they use digital scrolls and they worked off supply air temperature. They ran all the time and the supply air temperature was kept at 19 degrees C. That's what it was set for. So You walk into that room, everything in that room was 19 degrees C because the supply air temperature was consistently 19 degrees C and it always maintained that forever.
Yeah.
So I've noticed that from a pharmaceutical standpoint, but you transfer that into like a residence where everything is the same temperature that you touch, it provides unmatched comfort, right?
Yeah, that's what you want. I call that, you want it to be a boring infrared picture where everything is the same color. I've got a couple pictures in my book of just that. And that's what you want. You want everything to be the same temperature if possible. You have to have a good shell to really make that true. But even without a good shell, you can get a lot of the benefit. And yeah, like we have full agreement on like that is not a point that has been hammered home. Because also like radiant temperature, so radiant heat transfer is about 60% of human comfort. So if you aren't dealing with it, you're missing more than half the equation.
How do we achieve that? What do we do to achieve that?
You want as small of a system that dials down as far as possible. Because in playing with some numbers in the Cleveland area, assuming a house that had like a 3-ton heat load and a 2-ton cooling load, just kind of throwing numbers at it, that's a reasonable thing. Like, it sounds low, but I'm surprised. Like, about half of houses in the Cleveland area, which is similar climate to Toronto, I think you could pull the furnace out, put a heat pump in, and people would be more comfortable and not even realize that something else changed, that their heating bill changed. If you only have 10,000 BTUs, that doesn't sound like a lot, less than a ton. That would cover something like 80% of the hours of the year. So you
In
don't
certain
need very
applications,
much.
yeah.
So, and that's a house that has a load about triple that. You really don't need much heat most of the year. And it's kind of surprising when you see what's going on. So if you have a system the best modulating furnaces in general, the common ones, so like a 60K mod furnace will only dial down to 20,000 BTUs. So it is double what you need 80 or 90% of the year. That's a problem. You can't load match at that point. Now, even if you do like a 3-ton heat pump on that, that's going to dial down to 9,000, which is pretty good. So that'll cover you a chunk of the year, but you're still going to miss a wide swath of the hours of the year being able to load match. So if you can do a 2-ton and you get down to 6,000 BTUs, like 6 and 9 doesn't sound like a huge difference, but it's surprising how much of the year that 3,000 BTUs is important for load matching. So, I mean, that's your spring and your fall, and at nighttime in the summer, you really don't need that much heat or cool. And it's surprising when you actually watch houses operate.
Yeah. So the shoulder season, we're experiencing, like, it's probably similar with you guys, but the summer was hot as balls, and all of a sudden the temperature just dropped right off, and it feels like it was either one or the other. There was no transition period into the cooler temperatures.
Yeah, the joke here is spring was nice this year. Last year it was on a Tuesday.
Yeah. So in those situations, like, I haven't turned my furnace on yet. I should, because I always tell people to turn it on in September, make sure it works. But I haven't turned it on yet. And I know if I did right now, it would probably run for about 5 minutes and shut off. And
Yeah.
that's not good. It's not good for the
Your couch is going to be
equipment.
cold. So
My
your
couch
butt's
is going to be cold. Yeah, my couch is going to be cold. So the same is true in the opposite for dehumidification in the shoulder seasons, right? Because we may not have a sensible load. We might not be sitting at 80 degrees in the house or 78 degrees in the house or whatever it may be. We might be at temperature, but we have this like uncomfortable moisture level in the home, and it feels sticky and gross. And the dehumidification factor of being able to dial down is important as well, right?
What I've come to look for in equipment is equipment that can run an icy cold coil at minimum compressor, and very few pieces of equipment are actually capable of that. So their airflow usually can't dial down as much as the compressor can, and that's a problem. So, and what the spec sheets don't show you. So, like the Daikin Fits that I was talking about, and my wife was like, "This is a really comfortable little house." I bought those because my buddy Roman Baugh, who's at Kalos now, he was working at Daikin, and he's like, "Well, get one of these; they're awesome." But there were no specifications to understand what its dehumidification capabilities were at partial load.
Mm-hmm.
They're awesome,
Okay.
but I had to buy and install the system to figure it out.
Yeah.
To know where I have a
what
Bosch
did
on
you
this
find out?
house. The Bosch I put on this house doesn't dehumidify well at all. The coil just won't get cold enough.
Okay.
And so my dehumidifier uses more power than my air conditioner pretty much every month in cooling season. And I don't like that. And if I don't run the dehumidifiers, I run 70 to 80% relative in this house. It's very uncomfortable. So I'm actually about to pull the system and put in one that I know does a better job, which is kind of a wild move.
Now, the Daikin Fit, you said you had to install it to understand how it dehumidifies. What did you find out?
It's badass. So it basically, if it's 75 degrees, or was that like 22 C or higher. So basically, if it's a sunny day and just slightly warm, it will keep up with latent load. But the challenge is, I live in the mountains here. And so like our cooling design temperature is 83, which is what, like 28 C, something like that. So it's a pretty low cooling design temp. And so we have a lot of humidity, but not a great deal of actual sensible load. So like it's gross. Like we just had a baby, like an idiot. I'm 47. I've got a 9-month-old. We left his stroller on the front porch, and it molded up just sitting outside for like 2 weeks. It was just like it was covered with mold. I'm like, oh, this is awful. I had to go, spend an hour cleaning the thing. So I could put my kid in it. Some climates are really challenging on the dehumidification fronts, and this is the hardest one that I have been in, because we spend so much time in what would be considered shoulder conditions.
Okay, so let me ask you this. With a system, a heat pump, okay, actually, let me go back first. So the Daikin Fit that dehumidifies well, was that a matched air handler with it? The Daikin Fit matched air handler? It wasn't like just an off-brand furnace or something that somebody's doing a dual fuel with.
No, and that's actually, well, that is a fully communicating system, which I've kind of come to the conclusion, if you want really good latent control, you probably have to run fully communicating. Like technically you shouldn't have to. You should be able to do it with various solenoids and so forth. But realistically, I don't expect most installers to be able to do that well. So if it's a communicating system, at least I can commission it with the thermostat. Or maybe with tip switches to do what I want.
Yeah, I guess the downfall of a 24-volt system is that the compressor doesn't know exactly what's going on. It's just an on-off. Even though it's a modulating compressor in that unit, it's going to be hard for the system to know what the temperature is inside the home potentially. If it's, let's just say it's a furnace because you're doing a dual fuel, you've got a modulating system outside. But how does that modulating system know what the temperature and humidity is inside if you're just using a 24-volt stat and it doesn't communicate that to it? That would be the counter argument for that, right?
I tried the Bosch on this house to understand, could I get away with a 2-stage system? And I'm not going to say that you can't ever, but on this house, it wasn't a good idea.
Different places, different applications for sure. I was heading somewhere with my next point. So we were talking about, I asked you about the Daikin Fit and if you used the air handler, and you did. So the other question to that, the second part was, what are you doing for auxiliary type heat? Do you have electric reheat there? Yeah.
Well, no, the Daikin Fit doesn't have reheat. I just have a little $250 dehumidifier in the basement to tackle the rest. And it uses a decent chunk of juice. And I wrote a very detailed article at Thanksgiving last year showing what the energy use was of reheat versus the dehumidifiers. And they were effectively the same, is kind of what the numbers are. We'll see this year, because on my one system that has reheat, that house, it was kind of dumb. I walked in one day, I'm like, it smells funny in this house. What's going on? And while the dehumidifier I have there has a pump on it, it still managed to fill the tray and the dehumidifier shut off. And I just didn't catch it. I mean, I'm not there all the time. It's a rental and it's usually busy. And so I dumped that and I changed the reheat setting from 52% target to 46. So it's using more power now, but it's still not crazy. The last time I looked, it was 650 kilowatt hours, which is like, $100, $120, something like that for the year. Who cares? Like your dehumidifier is going to use similar juice.
I didn't mean to say that, but after you started explaining, I'm like, wait a minute, did I just say reheat? I meant to say auxiliary heat, resistive heating for auxiliary for backup. Yeah.
Yeah.
So the Daikin Fit, you put the resistance heat in there for backup or auxiliary?
Yep, just a 5 kW.
Okay.
I've got 5 kW on 3 of our systems because I now own 10 heat pumps, which is kind of wild. Most of them are mini splits. The Carrier one that I have with reheats, that has one system I really like, which is a 3-stage coil. So it's a 369 kW, which is really nice. Because people are like, well, are you going to size for just helping the heat pump, or are you going to size for full heat load? And with that product, I get both.
I got to walk the line because we have to look at the other side of things too. For the service technician, which I am, going to service a heat pump in the middle of February when there's 2 feet of snow on the ground in certain places is not fun. I think that might be a deterrent for some people to install a heat pump, because now I got to work outside. And when their heat's down, they're breathing down my back and it's freezing outside. I can't feel my fingers. It's cold. I'm walking through snow. I'm trying to bring a recovery machine and a vacuum pump to make this repair outside in the middle of the winter, rather than just going into somebody's house and working on their gas furnace where I'm warm and cozy and I don't have to deal with snow and wind and all that. So give me your thoughts on that, because that is a legit argument. And I've heard a lot of people say it. Hey, man, I don't want to work on a heat pump in the middle of the winter outside. I'd rather be in the basement working on a furnace.
Well, they're not wrong. I mean, in theory, but if you install it well, I don't have many of these things go down. I really don't. But one other key thing is, if you're running an inverter, you better have surge protection on that system, because if anything's going to eat it, it's going to be a power surge. You're going to lose a board somewhere. So that to me is the biggest thing. The other side is run a hybrid. Have both. So you have two fuel sources. But even with a heat pump with the strip heat, you still have a secondary form of heat. I don't know about you. I haven't seen strip heat hardly go out. I mean, unless you lose airflow across it, strip heat just doesn't fail. I mean, I've seen 40-year-old systems that are completely roached out as far as the compressor goes, and you turn on the resistance heat, it smells horribly of dirt burning, but it fires up and it heats the house. So resistance heat is super reliable, and I like having that.
It will heat the house. The resistance heat has enough kilowatts to match the load of the house. So this is an argument. I'm going to ask you this too. I was at a home last year. Somebody had a heat pump installed and it wasn't working. It was making noise. They called me. I went out. It looked like the compressor had failed, but he said it was noisy up till that point. So I wrestled with the manufacturer. I wrestled with the distributor first, and I got nowhere with them. So I wrestled with the manufacturer after, and I said, listen, instead of giving me a compressor and 2 boards under warranty, why don't you just give me a new outdoor unit? The distributor didn't want to do that through the manufacturer. And then I got a hold of someone that was high level of the manufacturer. And I said, listen, man, come on. The thing's only like a year old or a year and a half old or something like that. And it's under warranty, the compressor, not just give me a new outdoor unit and make this guy happy. And it makes you look good as well. So after a little bit of wrestling, that's what we did. But during this time that I was wrestling, he had some electric space heaters and he had a fireplace, and he also had the electric resistive heat strips in the air handler. But when he just ran the heat strips in the middle of the winter, he could only get his thermostat up to, and I got to go back to Celsius because he was set for Celsius, to 17 degrees. That's as high as he could get it. So here's a question I'm going to ask you. In some applications, should we look at sizing the resistive heat to match the load? Just like we do with a dual fuel system. We'll match the furnace to take over the whole heating of the entire home if the heat pump goes down. But should we look at doing that with the resistive heating as well, instead of just adding that little bit of auxiliary?
I think that's it depends. And that's part of why I mentioned like the 3-stage system the Carrier has, or most manufacturers have a 2-stage. You can get a 5, 10 kW system. That's where I would prefer to have the 2-stage. There's really no more complexity in adding one of those. It's a controls thing, but a good control just deals with that anyway.
The only complexity would be running the actual power to run it, because the first one I did, the guy had to upgrade his panel because he didn't have enough room, because we put in a 10 kW and he didn't have enough room on the panel. So he had to upgrade the panel so we could put a 60 amp breaker in for the heat strips. Right. So that would be the only complexity there.
And that would be an argument for a hybrid at the end of the day, in my mind. If you only have a 100 amp panel, yeah, maybe you need to do that. Now, to be fair, a 100 amp panel will run a lot more than people think. If you get an energy monitor and you watch what actually happens, the rough numbers are 100 amps times 220 volts is 22,000 watts that it'll do, 22 kW. 22 kW is quite a bit. So one of our houses, the one that has the 369 strip Carrier system, that just has a 100 amp panel, and I left it on purpose. And I'm going to add an EV charger to it too. It'll do it. The EV charger, that when it sees the panel nearing capacity, it shuts down the charger temporarily. All of it's doable. But if any of that stuff makes you nervous, run a hybrid, keep your furnace. I mean, another key argument that I don't see getting made is one-way air conditioners are stupid. You're paying almost as much for only half the capability.
That is one of the biggest selling points of a heat pump. Believe in it during the cooling season, because it's going to save you a hell of a lot of money during the cooling season. and it's going to match your load. It's going to dehumidify, and it's going to make it way more comfortable in that home.
I actually have my first furnace. We just bought another house, and it came with a 7-year-old furnace and air conditioner. And we've been spending way too much money on all these upgrades. So I'm just like, I'm not going to bother changing the system on this for now. I'll wait a couple of years. But it has a PSC blower that uses 500 watts when it's on, where my other systems to move 300 CFM are 25 watts to 50 watts. And even at full song, they're maybe 200 watts. So they're using less than half the power for the blower. And then that's a little 2-ton unit. And it's using about double the power per day for the compressor that the Daikin Fits are for houses with similar load. Not exactly the same, but it's not double the load. So it's been interesting to watch that. If you can move to an inverter, whatever that looks like, I don't like to harp on energy savings hard. It does help you in the cooling season.